In lesson 3.4, we're basically taking lessons 3.2 and 3.3 and just combining them. So once again, you're going to use the same exact rules you learned when you were solving equations, and then the only thing that you're going to add to it is the rule that you learned about multiplying and dividing by negative numbers with the inequalities. So over here, just make sure, follow the same steps. For isolating a variable, and then just don't forget that new rule. And the rule is, when you multiply or divide, multiply or divide a negative number across the inequality, the direction of the inequality switches. So that when you multiply or divide a negative number across the inequality, then that direction of that inequality needs to switch around. And that's the rule you learned yesterday. So hit pause, finish writing that, and once you're ready, play. Example 1. Solve 7 plus 6a is greater than 19. So we're not going to graph these with the examples because I think you've had enough practice graphing, but on your homework I am going to have you choose a couple to practice graphing with. So you isolate your variable. There's your variable. That's what you're trying to get alone. So you just follow the same rules we did in equations. Remember, terms without the variable need to move across before terms with the variable start splitting up. So first thing you would do, opposite operation, add a negative 7 or subtract 7, however you want to look at that. These become 0. You end up with 6a is greater than 12. Now you're still trying to isolate that variable, so you divide by 6 because it was multiplying, and you get a is greater than 2. And that's your answer. There was no negative rule going across by multiplication or division that you needed to apply. So that's what you're going to be doing with those. It's exactly like solving equations, but you just need to watch for that one new rule that you learned. Alright, let's go into example 2. Go ahead and copy down example 2. Once you're done copying it, then hit play again. So first thing you want to do with these is you want to apply that idea of looking for important information. So length is 18 feet would be important information. You can't use more than 48 feet of trim would be important. What are the possible widths would be important. So first thing I would do if I was solving this is I would draw a picture and start labeling things to think about it. So if I had this banner, I would label my length as 18 feet. My width is my question mark. And then I need to stop and think about what trim would be. Would that be area or would that be perimeter? And because it's trim, it just goes along the edge. So I'm looking at perimeter, which means that my perimeter has to be some relationship to 48 feet. So now you have to stop and think about that inequality there. Is your perimeter going to be greater than 48 feet, or is it going to be less than 48? And because of the words more than, it can't be more than, then we know that the perimeter has to be less than 48 feet but it can also be equal to it. So it's always easiest if you set that up before you start trying to do everything else, or you wait till the very end to look at it. Now to find perimeter, you just go ahead and add up your sides. So when you set up your inequality, so we're going to put add sides because we know we're finding perimeter. So when we set up our inequality, we have 18, and a lot of you have learned this as 2 times 18 plus 2 times W, but I'm just writing it out the long way so that there's no confusion there. There's my 4 sides, and I already figured out that that has to be less than or equal to 48. Taking it from there, perimeter is less than or equal to 48. That's my perimeter, and it's less than or equal to 48. So now I'm just going to go ahead and I'm going to solve this inequality. I have 2 variables there that are the same. My line going out, so I can combine like terms. I have 18 plus 18, which is 36, plus W and W, which is 2W, not W squared. W squared would be W times W. This is 1 plus 1, which is 2, bring your like term down, which is less than or equal to 48. Now I'm still trying to isolate that W, so I'm going to go ahead and subtract 36 since it's a term that's by itself across, and I end up with 2W is less than or equal to 12. And then I'm going to continue solving for W. So I divide by 2, and I get W is less than or equal to 6. And then again, you need to stop and think about, what did you just find? It's always important to answer that with what you found. And hopefully you all realize you found the width of the banner. Any width of the banner can be 6, it could be 5.5 feet, it could be 4 feet, it can be 2 feet. It can't be over 6 feet. So you write that in words. The banner width can be 6 feet or less. Okay, or something along those lines, that you're saying that it doesn't have to be 6. It can be less than 6, it just can't go over 6. This is example 3, so go ahead and write that down. Hopefully as you're writing it, you're already making mental notes about what you're going to need to do before you can start to isolate your variable. You should always be paying attention for certain things in equations and inequalities. So as you wrote this down, what did you notice right here? Hopefully you noticed that you needed to distribute. So whenever you see that, you always want to distribute first when you need to. Or some of you might remember that rule about trying to isolate just this and then divide. But if you notice, one of the problems in this case is that you have a T here and a T here. So you're actually going to need to combine those. It's not going to help you if you tried to move that away first. Once you do that, you follow the rules that you already know. Combine like terms. On the same side, then isolate the variable. So what I want you to go ahead and do is hit pause and try this. Try using any of the rules that you've learned, and then once you're done, hit play and check through it with me. Maybe you want to do it in pencil in case you make a mistake, or just write small enough or leave space below it so that you can rewrite it if needed. So go ahead and hit pause, try it, and then hit play when you're ready. Alright, so you should have distributed 2 times t, 2t, plus 2 times 2, which is 4. Then you just bring down the negative 3t, bring down the greater than or equal to sign, and the negative 1. Now you draw your line, and you go ahead and start looking at what you can do. So you notice you have like terms on the left side right here. 2 minus 3 should have been a negative 1t, and then you still have plus 4 is greater than or equal to negative 1. Now, if you have a negative 1 there written, you aren't wrong, you just put a 1 there. You don't have to have that 1. It's the only coefficient you don't have to write in. Now, you're trying to isolate t. Keep that in mind the whole time. You're not trying to isolate negative t, you're trying to isolate t. So, next step would be subtract 4 from both sides. Now you have a negative t is greater than or equal to a negative 5. Same term, add them, keep it negative. Okay, you're still trying to isolate t. So stop and look at that negative sign and think about what you're going to have to do to be able to move that across. And you have two options. Your two options were either to divide both sides by negative 1 or to multiply both sides by negative 1. I'm going to go ahead and show it as a division this time. My negative divided by negative becomes a positive. T divided by 1 is t. So I have a t that I bring down. Now, I brought a negative across through multiplication or division, so as I'm going over here, I'm going to go ahead and turn that around now so that I don't forget. Because if you forget, then you're still going to be wrong. Negative divided by negative is positive. So that is my final set of solutions. T must be less than or equal to 5, which means I could plug in 4.7, I could plug in 4.92, 4.99, I could plug in 5, but I can't plug in anything over 5, and it would always be true. Go ahead and write down this example, and I want you to do the same thing. Write it down, draw your line out of your inequality, use the rules that you already know to try this, and then hit play when you're ready. Should have had your line right there. Now you notice there's nothing you can do on the left, nothing you can do on the right, but you do need to get your variable to one side. So you're either going to move 4z over or 6z over. I notice that if I subtract 4z from both sides, I keep a positive here. So I'm going to go ahead and subtract 4z, or add a negative 4z. I end up with 2z minus 15 is less than 11, positive 11. Now I have my variable to one side right there, so I'm going to start working on isolating it. Move this term first, so I add 15 to both sides. I end up with 2z is less than 26. And now I'm going to go ahead and divide both sides by 2. And I have z is less than 13. I didn't have to flip my inequality around because I never multiplied or divided by a negative. Always look for that at the end. Write this example down, hit pause, try it. This is just another type of problem you're going to come across. Same rules you've already learned apply. And then once you're ready, hit play. You should have started with a line and then distributing. So I have a negative 3 times 4, which is a negative 12. Now be careful, this is where a lot of you have been making mistakes. Negative times negative is positive. Now 3 times m is 3m. I always look at those individually so I don't lose a sign. Greater than or equal to 2 times 4m is 8m. 2 times a negative 14 is a negative 28. From here, you need to get m to one side. I would move 3m over because it stays positive. Sometimes it doesn't matter in the end, but it's always worth trying. I end up with a negative 12 is greater than or equal to 5m subtracting 28. Right here, when you cancel those, always look to make sure that they're actually canceling. Sometimes if you accidentally added 3 to both sides here, you would notice, well, wait a minute, 3 plus 3 is 6, not 0, because you want it to actually cancel. Okay, now I have variable to one side. I'm going to work on isolating that variable. So I'm going to go ahead and add 28 to both sides. I need to be careful because 28 is the larger of these two, and it's a difference because they're opposite signs. So I have to actually take 28 and subtract 12 from it, and I get 16 is greater than or equal to 5m. 28's cancel. Divide by 5. So there are 4 ways to write this answer. All 4 are correct. Problem is, on multiple choice, they're only going to give you one of those options. So you need to be aware of the different ways that you can write these so that you can look for them whenever you come across them in a multiple choice. So we're going to go ahead and just show all ways to show the same answer. So the first one would actually be what we came up with at the end. 16 over 5 is greater than or equal to m, and you're done. You can also convert this to a mixed number. 5 goes into 16 3 times, with 1 left over out of 5. It's greater than or equal to m. The other thing that you can do, this is where we've talked about in the past, you just have to be really careful. If I was to read this backwards, it would say m is less than or equal to 16/5. So you write it that way. M, notice my arrow's pointing at the m there. Keep the arrow pointing at the m. 16/5. This means the same thing. 16/5 is greater than m. M is less than 16/5, or equal to. And the other way I could write it as a mixed number, 3 1/5. M is less than or equal to 3 1/5. So get used to seeing all ways of seeing that, especially when your variable ends up on the right.